In this video I'm going to talk about deriving a particular type of implicit Runge-Kutta method called a Gauss Legendre method. Okay, these Gauss Legendre methods, they're quite useful because they allow us to use a maximum order for the number of stages. Now an S-stage Gauss Legendre method can have order up to 2s, or has order 2s, sorry. Okay, so for example, if we had a two-stage method, that'll give us a Gauss Legendre method will be give us of order 4. Now Gauss Legendre methods, they're derived by using a Legendre polynomial. Now a Legendre polynomial are the solutions to the Legendre differential equation, and these can be written as Pnt is equal to the summation of k0 to n of n choose k, n plus k choose k, that's t minus 1 to power k. Okay, so this is an nth order Legendre polynomial. One thing I should stress here is this here is a binomial coefficient. Okay, it looks like a vector in the notation, but it's actually a binomial coefficient. As a bit of an aside, easy way to calculate the binomial coefficient is to construct Pascal's triangle. So here, obviously, each number is a sum of the two numbers above it. So let's say we wanted 3 choose 1. So what we'll do is we'll count down. So this is the 0th row. This is the first, second, and third row. So if n is 3, we're on this row. And counting across, we've got k is 0, k is 1, k is 2, k is 3, etc. So this is k is 1. So 3 choose 1 would equal 3. Okay, so how does the Legendre polynomial help us in deriving an implicit Runge-Kutta method? Okay, so what I'm going to do is just move on. And what we can do is the c values. So our c values are the roots of our Legendre polynomial. So the c values are the roots of the Legendre polynomial. The b values satisfy the bk condition, and the a values satisfy the c k over 2 rounded down condition. So just to remind us, so here we have the our order conditions. Okay, so we calculate c by calculating the roots of our Legendre polynomial. We calculate b to satisfy this condition, and we calculate a to satisfy the ck condition. Okay, so I'm going to have a look at an example. And the example I'm going to look at is given in the notes, and this is example 3.2. So example 3.2 simply says derive a fourth order Gauss Legendre method. So I mentioned before, but an order, an S-stage Gauss Legendre method has order 2s. So in our case, we have s equals 2. Okay, so what we're looking for is a method with a butcher tableau like this. Okay, so let's derive or calculate what the c values are. So for the c values, we got to find the roots of p2t, so the second order Legendre polynomial. Okay, so that's going to be 2 choose 2, 2 choose 0, 2 choose 0, t minus 1 to the power 0. So that's when k is 0, when k is 1, 2 choose 1, n plus k will be 3, choose 1, t minus 1 to the power 1, and when k is 2, we've got 2 choose 2, 4 choose 2, t minus 1 to the power 2. Okay, so we're just going to work out what this is. So we got 1 times 1 times 1, Okay, so we have 2 times 3 times t minus 1 to power 1, and here we got 1, 4 choose 2, that's going to give us 6, sorry, 2 choose, so 2 choose 2 is 1, 4 choose 2 is 6, I've got 6 times t minus 1 squared. Okay, so if we simplify this, eventually we get to t squared, 6t squared minus 6t plus 1. So that's our second order Legendre polynomial. Obviously we want the roots of that, so using the quadratic formula, the roots will be minus b plus or minus square root of b squared, which is 36, minus 4 times 6, which will be root 12, all over 2a, which will be 12, and this is equal to 1/2 plus or minus, divide 12 by 4 and take it outside the square root, we get 2, so 2 over 12 is 1 over 6, and 12 divided by 4 is 3. So t in this case, the roots are 1/2 plus or minus root 3 over 6, which gives us ci. Okay, so for example, c1 is 1/2 minus root 3 over 6, and c2 is equal to 1/2 plus root 3 over 6. Okay, so we've got our c values. We've got c1 and c2. Our b values satisfy the bk condition. Now, in our case, k is 4, but we only need 2 stages. We only need to solve for b1 and b2. So even though it satisfies up to k is 4, we actually only need to go up to k is 2. Okay, so I'll just explain a bit more about that. So the bk condition, so the b values satisfy bk condition. Okay, so if I just right. So remember, we have b1, b2. We just got a two-stage method. So the first b condition is simply the sum b1 plus b2 equals 1, and the second condition is b1 times c1 plus b2 times c2 is equal to 1/2. Okay, I don't need to go any further, okay, because this is enough to solve for b1 and b2. Okay, the a conditions satisfy the d, so aij satisfy the ck condition. Okay, actually I should be a bit more accurate here, it's k over 2 rounded down. Okay. So in our case, when L is 1, we have what is known as a row sum condition. So A11 plus A12 has got to be equal to C1, and the same with the second row. Right, and we also have when L is 2, so we have A11 C1 to the power L minus 1, so that's C1 plus A12 times C2 to the power L minus 2, and that equals 1 over L, so remember L is 2 here, times C1 squared, and similar for the next row. So 1 over 2 times C2 squared. Just to remind you, I mean, I could have written down lots more order conditions which are satisfied up to 4th order, but because we've only required 2 stages, we can stop here. So we have 3, 4, 5, and 6. We already know what C1 and C2 are, so we have 1, 2, 3, 4, 5, 6 equations, and we've got B1, B2, A11, A12, A21, and A22 as our unknowns. So essentially what we do is we solve, and usually solve using software. Okay, you can solve it by hand, but you know, nobody's got time for that. Okay, so if we were to solve for our example, okay, what we'd find is we already know what C1 is. So C1 is 1/2 minus root 3 over 6. C2 is equal to 1/2 plus root 3 over 6. B1 is going to be 1/2, and B2 solves to 1/2. A11 it solves to be 1/4. A12 is 1/4 minus root 3 over 6. A21 will be 1/4 plus root 3 over 6, and A22 is equal to 1/4. So these were solved. I mean, you could use MATLAB, Python, Wolfram Alpha, so any sort of software. So if we were to actually draw out our butcher tableau, so we've got B1 and B2 is 1/2, 1/2. C1 is 1/2 minus root 3 over 6, and 1/2 plus root 3 over 6. A11 and A22 were both 1/4. A12 was 1/4 minus root 3 over 6, and A21 is 1/4 plus root 3 over 6. Okay, so what that is that's our fourth order Gauss Legendre method.